Building a simple chat wrapper takes an afternoon, but when you need an AI system to process sensitive healthcare data, handle thousands of concurrent queries, and execute complex workflows without failing, that simple script collapses into a massive orchestration problem. To separate the engineers who build prototypes from the architects who build production systems, Anthropic created a definitive benchmark, the Claude Certified Architect credential. Earning it requires surviving a strict 90-minute gauntlet. You have to answer 60 complex questions and hit a 70% passing threshold. The test does not care if you can memorize API documentation. It forces you to evaluate live architectural trade-offs under constrained environments, like balancing latency and token cost for a massive SaaS platform while mitigating compliance risks. Walking out with this certification proves you have the engineering capability to take a fragile AI concept and harden it into a compliant, enterprise-grade pipeline. Preparing for that level of scrutiny requires equally rigorous training. That is where the Mastering the Claude Certified Architect exam course comes in, offering 5 complete exam-grade practice tests. Across 300 scenario-based questions, you are dropped into live production issues. 1 minute, you are diagnosing throughput bottlenecks in a high-volume product, and the next, you are securing data pipelines to meet strict healthcare compliance standards. Knowing the right answer is only half the battle. This course provides deep technical rationales for every single option on every question. This decision tree maps failure modes of incorrect alternatives. You see how one misconfigured parameter cascades through the architecture, causing system failure. To ensure you learn the logic, the engine randomizes questions and options on every attempt. True architectural mastery requires understanding exactly why systems break under pressure. This course forces that level of comprehension before you sit for the real exam. Let's look at exactly what you need to build to pass. Every robust architecture starts at Domain 1, placing a core compute node at the base of your system blueprint. Here, you have to map strict business constraints, like available budget and required speed, directly to your available compute options. This animated diagram illustrates the trade-offs between Anthropic's models. If you need maximum intelligence for a complex reasoning task, you route to Claude Opus, driving up token cost and latency. For faster, high-volume tasks, you toggle to Haiku, dropping the cost but sacrificing deep analytical capability. Sonnet sits in the middle, balancing output quality with speed. The context window, the total amount of text and image data the model can process at once, dictates how you feed information into this node. You must design streaming strategies to handle complex, multimodal vision inputs efficiently without overflowing the token limit. When high user demand hits, you will face rate limits. To prevent dropped requests, you must implement exponential backoff. Exponential backoff is an algorithm that progressively increases the wait time between retry attempts after a failure. Choosing the wrong foundation model or failing to handle capacity limits ensures your system will suffer from latency spikes and cost overruns before a single prompt is evaluated. Moving to Domain 2, we build the second architectural layer, the input router. This is where you design production-grade system prompts to guide the model's behavior. To guarantee predictable outputs, you have to structure your inputs using XML tags. XML, or Extensible Markup Language, uses text tags to define clear hierarchies of data, ensuring the model parses instructions deterministically instead of guessing at the format. You also have to intelligently manage strict context budgets. Techniques like chain of thought and extended thinking force the model to reason step by step, which drastically increases token usage and requires careful allocation. This visualization shows the input router acting as a defense mechanism. You must build sanitization pipelines to harden your system against prompt injection attacks, where malicious users try to override the system prompt with unauthorized commands. Without rigorous context management and structural enforcement at the input layer, the AI operates as a fragile black box, entirely unsuitable for enterprise engineering. For Domain 3, you connect the AI to external databases and systems using strict tool use. Every external tool must be explicitly defined using JSON schema. JSON schema is a vocabulary that allows you to annotate and validate the format of JSON data, guaranteeing the AI knows exactly what parameters an API expects. This flow diagram contrasts execution strategies. If a user asks for weather data in 3 different cities, you can force parallel tool calls, firing all 3 requests simultaneously. If the second action depends on the result of the first, you must sequence them, intentionally creating a bottleneck to maintain logical order. You control these flows precisely within the API request by setting tool choice modes. Toggling to auto allows the model to decide if a tool is needed, while any forces the model to use at least one tool before responding. When an external API inevitably times out, you return that error correctly using the tool result payload structure. This ensures the model recognizes the failure and degrades gracefully instead of crashing the process. Mastering execution flow control prevents slow external APIs from crippling your intelligent pipeline. Domain 4 elevates the blueprint from single-turn request flows into complex, asynchronous multi-agent architectures. This is the orchestrator sub-agent pattern built using the Claude Agent SDK. A central model evaluates a complex objective, breaks it into discrete components, and delegates them to a ring of specialized sub-agent models to process simultaneously. To feed these agents, you integrate MCP, or Model Context Protocol, servers. MCP is an open standard that provides a secure, universal connection layer, allowing all sub-agents to safely query your external data environments. When these agents execute long-running tasks spanning hours or days, you face the massive engineering challenge of managing state resumability. If a server restarts, the orchestrator must be able to pick up exactly where it left off without duplicating work. You must also design strict human-in-the-loop checkpoints. Before any autonomous agent executes an irreversible action, like dropping a database table, it must pause and wait for explicit human authorization. Robust multi-agent orchestration allows an AI to function as a semi-autonomous enterprise workforce rather than a tool for single-turn text generation. In Domain 5, you have to lock down this workforce. You wrap a strict security boundary around the entire multi-agent pipeline to protect user data and prevent enterprise liability. This requires implementing the minimal footprint principle, ensuring every agent operates under a least privilege design. An agent should only have the exact data access necessary to complete its specific task. This visual demonstrates auditing those network connections. You identify and permanently sever any unnecessary pathways between autonomous agents and secure internal databases to minimize the attack surface. Within this restricted boundary, you deploy automated content moderation. This secondary filtering layer scans inputs and outputs, intercepting harmful or off-topic generation before it reaches the end user. You must guarantee that all deployments strictly align with Anthropic's acceptable use policy, which is a non-negotiable requirement when processing protected financial records or sensitive healthcare data. Without enforced alignment and a minimal footprint, a sprawling agentic architecture is a security vulnerability waiting to be exploited. Finally, Domain 6 covers the reality of pushing this secure system into a high-scale production environment. To control compute costs, a prod caching layer intercepts identical requests, serving saved responses instantly to bypass the expensive core node. Alongside this, real-time token budgeting monitors usage, automatically halting processes when limits are reached to prevent massive billing overruns. To maintain reliability under heavy load, you manage connection pooling, which means reusing active database connections instead of continually opening new ones, and you leverage efficient streaming protocols. Once live, you continuously evaluate a system's performance using LLM as judge frameworks. This technique uses a separate model to automatically score your pipeline's outputs against validated golden datasets. Golden datasets are verified, high-quality examples of correct system behavior. An AI architecture is only truly production-ready when its cost, reliability, and output quality can be continuously observed, quantified, and managed at scale. From foundational compute nodes and strict context engines to secure multi-agent swarms and precise token budgeting, we engineered a fully connected enterprise AI architecture. Designing, debugging, and safely deploying this level of system complexity is exactly what Anthropic expects from a Claude Certified Architect. Mastering these highly specific engineering trade-offs requires the live-fire practice provided by the 300 scenario-based questions in the prep course. Enroll in the Mastering the Claude Certified Architect exam course today to validate your expertise, lock down your architecture, and walk in with complete confidence.